Okay, so when we solve, a lot of you did a very fine job doing this. What would you do to both sides first? Yeah, I would subtract 5, which then gets me 2x equals 4, and my final step is to divide. Very good. And x is 2. Okay, pretty straightforward. The reason why we're doing this is because that's pretty much what we're doing today, but in a little bit different terms here. This is something that you really have not done yet that I know of in Math 2, so this is something that's going to be new, and you need to make sure that you're focused on it. All right, here we go. So, got Aladdin themed on my notes this chapter. We're doing inverses of power functions. A power function is something like x squared. That's a power. It's a power of 2. Or x to the 4th power is a power of 4. X to the 5th power is a power of 5. Okay, so knowing that when I say power, I'm really talking about that exponent piece when I talk about powers. So if a function, when we talk about inverses, a function that interchanges the input values and the output values of the original function. Okay, so when I say inverse, and I try to get you guys used to that, when I kept saying inverses when we're solving, okay, when you solve for something, the inverse of adding is subtracting. The inverse of multiplying is dividing. So that's what I mean by inverse when we talk about inverses. Okay, so this means that the domain, which are our x values, and you all should know that, and our range, the y values are going to be switched. Okay, so when we talk about inverse functions, all of the x and the y is all switched. Okay? And it kind of makes sense because when you're solving for something, you're switching the sign of everything. Okay? When you moved the 4 over, or when you moved the 5 over on your bell ringer, you subtracted 5. Well, that was the opposite of adding it. That's why you did it. That's called inverse. So, in order to find a function and find its inverse, you have to do this kind of technique that really is just solving. It's pretty straightforward. It's just solving. So all we're going to do is we're going to switch that x and y, like I just told you. We're going to switch the x and y and then solve for y. Okay, so let's try that on our own here, or together. But before we do that, I kind of want to make you guys put it in words, because I think sometimes when you guys do math, you have no idea what you're actually doing. You're just doing a procedure that you've been memorized to do it, and I hate that. Which is fine, but I really want you to know what's going on. Like if you were to read this in English, in American English, I should say, how would you read this? Well, so minus 5 is good, but negative 3 what x? What's going on here? Negative 3 what to x? What's happening with, yeah, you're multiplying. So like if I'm trying to get you guys to put it in words, this really means negative 3 times x and then subtract 5. Okay, that's what's going on with the x. So when you do inverses, it's the opposite. Okay, so when you end up at the very end of your answer here, the inverse function should have adding 5 to it, and it should be having divided by negative 3 in it. Okay, that's kind of how this works. You should have the opposite. All right, so the very first step is to switch your x and y. So that's what I'm going to do. Here's my y, and obviously this is my x here. So I'm going to switch them. So my first step is literally no math. All I'm doing is I'm switching the x and I'm switching the y to find my inverse of a function. That's all I did. I took the x and y and I switched them in blue. Now we solve for y, just like you did on your bell ringer. Same exact problem, but we're not looking for the answer anymore. We're looking for something called the inverse function. So if I was solving for y, that means I want to get everything to one side, away from y. What would I do first? Yeah, I would add the 5. You say add 3 or 5? Okay, you want to add 5 because what's happening, remember we talked about what that 3 really means. That 3 really means multiplication. That's why we can't do that one yet. So I'm going to add 5 first. Now, I can't do x and 5. I can't combine them. They're not the same. So I just rewrite it. So x plus 5 equals negative 3y. Again, I'm still solving for y. It's a two-step problem. What do I do to both sides to get rid of this negative 3? Divide. Here's why again. That's why I'm trying to make you start reading these problems in your head as English. Negative 3 times x. So to do the inverse, I must divide. Okay, so a lot of people think because there's a negative there, I'm subtracting, but I'm not. I'm multiplying. So I'm going to divide by negative 3. And I get what's called the inverse function, and this is new. So it's just the notation that's switching for this one. And we're done. Because it's going to be x plus 5 all over negative 3. Okay, we're not solving for an answer. We're solving to find what's the inverse of the original function. And if you look at it, look, I told you that the inverse should be the opposite of what you wrote. Negative 3 times x. Well, look, we're dividing by negative 3 now. Subtracting 5, well, look, now we're adding it. That's what an inverse function is. It's the opposite. All the domains and all the ranges change. And you'll see that on the graph and what it looks like. It's pretty cool. What? Well, you don't know what we're really doing because I only taught you one problem, so I can understand why it doesn't make sense. You got to let me actually teach you another one. Okay? All you're doing is you're solving to figure out what the inverse function is. What is the complete opposite? So I'm starting with the first one, and I'm trying to get that inverse. So now when you go and you put this in your calculator, you can, but I'm going to give you the points just for the sake of time. So I'm going to give you these points. When you plug in all of this into your calculator, you should be given this point, all these points. That's the original. Remember, f of x is your original. This little negative 1, I'm even going to put a little, sorry, I just choked, a little arrow here and put, this means inverse. In order to tell me that you're talking about the inverse of the original, you must put a negative 1 here. That's what it means to be an inverse. So just like the notation, it's nothing mathematical. Now, when you do inverses, all you do is you switch all the x and y's. Okay, that's the trick with this. Everything changes, the x and the y's, but they just switch. So I have negative 8 here. So what am I going to have for my y value for the inverse? Yeah, so all I'm doing is I'm switching them. Then just go in order. Then I have negative 2, negative 1, what?
0.
And 1. So that's, again, proving to you the inverses, they all just switch. And that's why when you guys do this, you can tell if they're inverses of each other, because if they're not exactly the same but switched, then you know they're not inverses. So let's go ahead and graph this out. You guys can start plotting these points. Plot just this guy first. Plot just f of x. So start plotting the points. I know you can do plotting. You should be able to. I'll do one with you. Left 3, 1, 2, 3, down 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that one's done. And plot the rest of them. Which one did you plot?
The F of this one.
You went down. Check in, make sure your points are correct. Look. 0 up 1. 0 means I move not neither left or right, and then the 1 means I go up. Okay, right 1, up 1, 2, 3, 4. Okay. And I'm going to actually label that right here, that's my original, because we're going to plot the inverse and see kind of what they are comparing to each other, what they look like. It's kind of interesting to see what exactly they look like. What is the domain and range of all linear functions that go up and down forever and left and right forever? Domain and range.
Negative
Yeah.
positive.
Yeah. That means that it goes on forever up, it goes on forever down, it goes on forever left, and it goes on forever right. All odd functions will have those, unless you're talking about something that we did in chapter 9, which are rational. They might have discontinuities. Okay, now let's plot the other one. I'm using a different color here. So again, same thing, but now watch. They're all going to start switching, so go ahead and plot those ones. So I went left 8, and I went down 3. 1, 2, 3. That's my very first point right here. Okay, the negative means you go left, and the negative means you go down. So I went left 8, and I went down 3. Now do the rest of them. And I'm going to label this as my inverse. Because that way you know when you're actually talking about it or you're looking back at it that you know that that one was the inverse function and the green one here is going to be the original. But now let's talk about kind of what's going on here. Well, we know the domain and range is still the same because they both go on forever. Let's kind of just look though. Do they look, does it look weird? Like what's going on? Do you see any kind of symmetry that's going on here? You don't see anything that could be happening for symmetric?
Yes.
Yeah.
Yeah. The angles at the top and bottom.
Yeah, I totally get what you're saying. So here's what I'm going to kind of explain to you. And we're just about to get into it, and I kind of understand what you're saying. Let's just say I take this little green highlighter, and I draw this line. Do you see that if I were to fold it over, if I were to take this arrow right now, I grabbed it, and I flipped it over the line, it becomes this. Same thing here. If I took this green part of the arrow and I flipped it over the line, it would now become this function. That's, go ahead.
I was trying to say like the angles inside.
Oh, like the angles?
Yeah, they look
Oh.
top and top.
Yeah, I mean they will be congruent, you're right, but that's geometry. Okay? So, this is actually called the line y equals x, which we're going to get to on the next page, but this line y equals x is where it's symmetric about, which means, again, when I take the arrows or I take this part, it's going to be the complete opposite on the other side, which is true. If you look, I had 4 up 1. Well, here I went right 1 up 4, which was the opposite. Okay, that's what inverses are. Okay, so let's flip the page and do the next problem together. A little bit together. So inverts. We're talking about this function here. Think about the x. What's going on with the x? Would I add the 6 first? Or would I divide by 2 first if I put a number? If I put 1 here, what would you do first? Would you divide by 2 first or add the 6 first?
No, x plus 6.
It's x plus 6 first. Because look, aren't they both being divided by 2? So in this situation, that's like a whole group here. So I would add the 6 first, add 6, and then I would divide by 2. Okay, that's in words what's going on with x. I'm adding the 6 first. Like if I put in 1, I do 1 plus 6 is 7, and then I would divide by 2 mathematically. So when you're trying to find the inverse, again, it's the opposite. So I'm going to do what first? It's the opposite. We go bottom to top. What's the opposite? And then what am I going to do?
Subtract.
Subtract. So that's kind of getting you, so if you can say it in words, you can kind of see like what you're going to do. I originally am going to add 6 and divide by 2. My inverse is going to multiply by 2 and then subtract by 6. And we're going to see that that's true. So my first step is to switch those x and y's. Remember, that's your y right there.
This is that stuff I don't get.
So in order to actually create your function, because you don't know what it is, we know that all the x and y values switch, but we don't know what the actual function is. You're trying to find it. So in order to do that, because all the domain and range change, you just switch them and solve. That's like the trick to find it algebraically. So we're just going to switch it. This becomes x, and the x becomes y. That's the only part that you're doing. There's no math involved. I took the x, replaced it with y. I took the y, and replaced it with x. And then you solve for y to find your function. Because your goal is to find what is the inverse. I don't know. I got to find it. It's always going to be a 2-step problem. We're not going to make it hard on you. 2 steps. You're going to do what first? Kind of talked about it already. It's divide, but what's the opposite? Multiply. So remember, you always go from, when you write out in words, if you were to, you start at the bottom, go up, because that's what the inverse is. So I'm going to multiply by 2 first. That goes away, and I'm left with 2x equals y plus 6. Then again, in words, my next step was going to be adding 6, but in my inverse, what am I going to do? Subtract the 6, and then you'll be done here.
Wait.
Wait, what happens to the y?
I was bothered.
Remember, your goal is not to find an answer. It's not like, I don't want x equals 5. I don't want that. I want a function. I want you to tell me what the opposite function and what's the inverse function. The goal was to solve for y, so we should be okay now. Yes?
How could you subtract the 6 from the 2?
You can't.
and 2x?
You can't. So that's why it becomes 2x minus 6 equals y. Now, that's correct. I would 100% accept it. But if you want to be proper mathematicians, you have to show proper notation. Because this really is just any line in the world.
Wait, so you have to put
So I think you were kind of getting there, but remember what a function notation, so this is a line, this is an equation. This is a function. Remember, a function is like you're putting something in, okay? And this is an actual, just a line here. It's just an equation. So really it's not even mathematical. The only thing we're changing is making this inverse notation. And then the rest remains the same. All I did was I just changed this to be proper. You can leave it in there, but sometimes you guys get confused when we solve for something like that. So look, again, in words, the first one we were adding 6 and dividing by 2. And you guys told me we would be multiplying first and then subtracting by 6, which is true. Okay, that's what an inverse is. It's the complete opposite. Okay, here's what I want you to do. You're going to need a graphing calculator in this chapter, so if you don't have one, make sure you just raise your hand. I'll just give them to you now. Because I want you to practice putting them in your graphing calculator. And then at home, you can use Desmos to do that for yourself. Go. Perfect.
I actually didn't have the sheet in the first place.
So, I'm going to help you out here and go to your y equals. Hopefully you knew that when you graph something, you just go to that y equals in your graphing calculator. Mine's loading. Here a second. Okay, guys, you're doing some pretty advanced math. You should be pretty proud of yourselves. This stuff is pretty hard.
So I just take that and put it in the calculator and then just gives me the answer.
Well, it gives you the table, yes. All right, we're back. Here we go. Go to y equals. So in red is where you're going to see it. Now,
Wait,
yes.
for this boxes, couldn't you?
Sorry, I got distracted by something really
I was
random.
gonna say, like, for this, couldn't these be these and these could be these?
So Jacob just found a very cool trick. So you really wouldn't have to use your calculator, but I was just trying to show you what it would look like. But we don't know for sure if those are perfect matches. We don't know what they were doing on the notes. So let's just double check. Okay, so let's take a look. When you do this, remember what you told me. You told me that the x plus 6 is going to be going first. So in order to put that in your calculator, you must group them in this situation. So it needs to be x plus 6 divided by 2. And you're going to see your graph. Or what we really want is our table, because that's going to help us with our points. So we're going to press second, which is in red right now, and then graph, which is that table part. So let me know if you need help getting to that part of your calculator. So second, graph gets you that table, and now we can find the points we're looking for. On the notes here, we want -2. Well, I can see -2 is 2. Perfect. So I'm going to write that down. -2 is 2 on my graphing calculator. And then -1 was about 2.5. 0 was 3. 1 was 3.5. And 2 was 4. And again, the reason how I know that is because I have my graphing calculator right here, and that's what it told me. You could honestly just put in some points and solve for it if you wanted to. But.
I messed up. I don't know how to.
Okay. So what I want you to do is on that next graph, what happens to all the x and y values in inverse functions?
You hit second graph, right?
Yeah.
-5 and 0.5.
That's fine. You want -2, so you would just go to it.
Oh, okay.
Yeah, you can just scroll up and down. Yes, but we wouldn't have. We don't know for sure if that's what the notes were telling us. You know what I mean? Like they could have given us random points on the other side. So what happened? Yes. Question? No. What happens to all the x and y values when we are talking about inverse functions and their original? What happens to all of them?
They swap.
They swap. So you could just go ahead and write that out. -2, -1, 0, 1, and 2. Okay, take a minute and graph both of those. Make sure you label which one's which. So take a minute with yourselves or with a partner if you need help, or ask me for help, and graph what you just did. Both of them, please. Okay, you should be masters at graphing functions by now. Or at least plotting the points. So I'll do them in order. I'll do them in different colors.
This makes no sense.
How to plot a point?
Oh my god, I'm on negative. So this Let's do. Let's look.
So it should look something like this in my two colors here. And I labeled which one was which. So that I knew when I go back and say, okay, that was the original and that was the inverse. What's the domain and range of both of these? Very good. They're all real numbers. So negative infinity to positive for all of them. Okay. All right. So when we look at examples 1A and 1B, which is the first page and the second page, what do you notice about the graphs of the function? We know that the graphs, they all switch. They switch. But what was that line that I talked about that it's symmetric about? Does anyone remember on the first page? What line always will inverse functions be symmetric about? And I kind of talked about it up before. What is that green line? Y equals x. So I want you to actually draw in that. If you have a highlighter, great. If not, maybe put a dotted line there so that you know. It's literally just right through the origin. It's symmetric. You go up one to the right one, up one to the right one. That's the slope of it. That's what it's symmetric about. So it's symmetric about y equals x.
Is that SYMM?
Yep. SYMM.
So in a way, most of these will be looking like flashlight lights. In a way.
What do you mean by flashlights?
It means each of them will be growing larger larger the further away they are from each other. I don't know. This
is just linear. We're going to get into different ones tomorrow, but linear, we want to start really easy with linear today. You're going to see kind of a different thing tomorrow. I wouldn't memorize that that's what it looks like, but I get what you're saying. Okay, then we have a boo down here. Okay, saying that we can always expect these behaviors when we analyze the inverses. Okay, because what happened with the table of values, they switched. The x and the y switched. We knew that. Those are the two main properties of inverse functions. That they're symmetric about the y equals x line, and the x and y is all switch. Or the domain and the range is all switch. Okay? So the next couple pages, the next two pages are very fast because it's pretty straightforward. The first two pages we investigated, because I like to investigate with you guys sometimes and prove you prove to you why something is before I actually teach it to you. So I'll give you a second to make sure that's all copied down and flip when you're ready to go. Okay, on this next page, all it says is determine if the following functions are inverses of each other. What must happen to all the values in the tables in order to be inverses? They must all switch, every single one of them. So we're going to look. Do both of these switch completely? The exact same, but they switch. Yes. What about these ones? And these? 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 So are they inverses? Yes. They are inverses. Okay? Every single one of them must be exactly the same. Both the x becomes the y and the y becomes the x. That's what an inverse function is. Let's look at the next one. No, right here. Not even close. Well, the negative 9s were okay, but these pieces, and if you were to circle them so that you know that that's the reason why it is not. So no.
Well, I mean, it's not the only one that's wrong.
You're right, but if you have one of them, then you can just stop. Because you don't really need to check all of them. If one of them is wrong, then you're done. Okay, they're not inverses. Okay? We're going to cross out this one. I don't really care about that. So now, all I want you to do is do 3A. We already did it. We did it on the first page and the second page. We did all this. We switched them all. Okay? All I want you to do is take these pieces and make them an inverse function. How do you do that? Again, we switch the x and the y's because that's what makes a function an inverse function of the original. I want you to do both of them. When you're done and when you're done only with A, take a look and see if you got them right. All I did, again, was I switched the x and y. That's how you create an inverse function. You don't need it because I gave you one.
Oh.
So how would I, yeah.
Why wouldn't you need a table to see if it's wrong?
Well, if I only gave you this piece of this one and I took that away, I'd say yes.
Oh, straight.
But because I gave you both of them here, you can just go straight to here. Okay, so again, they switch completely. So I'm going to go here and just switch them. 7, 4, 1, negative 2, negative 5. And these all become here. Did you get those correct? Kind of want to see where you are. Hopefully you were able just to copy and paste something, but switch them. Do you have questions on that?
This is what our homework's gonna be like?
Some of it, yeah. Okay. This is just as easy, I promise. It's the same exact thing that we're doing, but now I'm giving you a graph. Okay? Just because we don't have tables doesn't mean we can't do what we just did. I have these points. So in green here, what is this point? I'm going to label this f of x just so I can talk about it. What?
Negative 1 and 3.
Yeah, so the point is negative 1 up 3. So I'm going to write that out for myself. What is this middle point here?
0, 0.
What is this other point off to the side here?
1, 3.
1,
Negative 3.
negative 3. There you go. Okay? Do you have questions on where I even got those points? They're coming directly from the line. I'm writing them out for myself so I can stay organized. What would I have to do now to make the inverse graph?
So just switch.
Yeah, just switch them. So you see how we're just a repetitive process. We're just trying to figure out what the inverse function or the inverse graph in this situation is going to look like. So I'm just going to go right underneath it, and I'm going to make the table for myself. Bless you. You don't have to do this. Bless you. You don't have to do this every single time. If you know, if you're like, hey, if you're someone that can just do this without organizing, fine. If you're like, hey, negative 1, 3, so that means I must have what on my inverse? What? Exactly the same, but switched. 3, negative 1. So 1, 2, 3, up, down 1 is that first point. Some of you can just look at that and say in your head, okay, I went left 1, up 3, so now I'm going to go right 3 and down 1. That's fine. You don't have to write this workout if you don't need to. but I'm going to. 0, 0, when you switch them, becomes 0, 0 again. What does this point become?
-3, 1.
Beautiful. 1, 2, 3, up 1. I'm going to go ahead and graph that in. And I'm going to label that for myself so I know that that was the inverse. Here is that line again. I'm going to ask you a million times until you're blue in the face. What is that line? It's symmetric about what is that? What is that dotted line?
Y equals X.
Yeah, I'm going to put y equals x here so that you remember. They're completely symmetric about that line. And I'm going to explain one more time on what that means. If I were to take this point and fold it over my hand, I'm going to fold it over my hand. Do you see how it becomes this blue one? Then same thing here. If I take this one, I grabbed it and I folded it over my hand, it becomes the blue one here. That's what it is to be an inverse. Okay, I want you to try the next one. Can you switch all the points? Let's see if you can at least switch them all. Again, here's how I would do it if you're someone that is pretty quick in their head. -1, 1, which means I must have
1, -1.
1, -1. Very good. Oh, look, it's becoming the same points, but this is the one up here in blue that's really going to help you. I go -2, up 1, 2, 3, 4, 5. So I must go,
-5,
don't change the sign. Just switch it.
5,
5, 1, 2, 3, 4, 5, -2. Okay. And then this other blue point, I go to the right 1, 2, and down 5. So now what am I going to do?
left 5,
I'm going to go
right?
left 5, 1, 2, 3, 4, 5, and then what?
1, 2.
Yeah, 1, 2. Good. So now those are my points. If you notice that these 3 points in the middle when you swap them, they became each other. It's kind of crazy. Connect the dots. Here we go. So watch me connect this. This one's actually harder to draw out. So I'm going to connect the dots left to right. Left to right. Looks like that. So when I go left to right and I connect the dots, that's kind of how it drew out.
That's not inverse.
Huh?
Yeah, but
They are inverses because now look. It is not time to go at all. We still have another page.
What?
Yeah, you guys need to stop getting used to the fact that we end early. I do that when I can. Okay, you guys are just getting in the habit of it, but here's what I'm seeing, and this is why I got mad yesterday. You don't utilize the time I give you, so why do I give it to you? But anyways, we have to do these notes anyways. We have to keep going. The next page is very quick.
So does it have to be straight to the inverse?
It does not have to be straight to be an inverse. Because look, if I take this point and I were to flip it over my hand, it becomes this blue point there. Okay, so let's go ahead and flip one more time. We're almost there. We can skip this one. Don't worry about it. But let's talk about what Aladdin's saying here.
Who's that?
Aladdin.
Oh my god.
Oh my God. So, he's from Aladdin in the movie. Okay. Aladdin. Okay. So, there was something called that vertical line test. You probably learned about it freshman year. That if you drew a vertical line, you can tell if it's a function or not. Okay, you might not remember that, but that's okay. We're going to talk about a horizontal line. The horizontal line test is going to tell us if our inverse is a function. Because that's going to make a difference tomorrow. So we are going to use that inverse function. If it crosses only one time, it is. So we can circle that one. If it crosses twice, it is not a function. Or more than twice. As long as it's only one time, you're good.
5 A's no, 5 B's yes, and 5 C's no.
Wow, I think that's the quickest I've ever seen you do math. That's awesome. Okay, I'm very proud of you. That's great. So, look, if I drew this line here, you can do a highlighter or a pencil. It crosses 1, 2, and 3 times, so it is not a function. The inverse is not a function. So I'm actually going to write that out. The inverse is not a function. So that you know what I'm talking about when we're doing this. This is a function. This graph alone is a function because it passes the vertical. But this one is, so yes. And this one is not 1, 2, so not. And now we're done. Okay? You have still more than 10 minutes left. Okay, so you need to work on this. This is what I was talking about yesterday. I give you all this time and the test comes and you're like, I don't know how to do any of it. But you don't ask me when I give you 15 minutes every day to do homework. And that's what kills me. It literally kills me inside. Okay. Tomorrow will be shorter than today. Alright? Letter 2, sorry, number 2 should be like 5 seconds. 6, 7, 8 should be 5 seconds. So the only ones that are actually a little bit longer, the first one, I'm walking you through it. I'm making sure that you're understanding it. So I'm telling you that I'm giving you the points, write them down, and then switch them. I walk you through it on the first one.
Number 3, you have to do that whole process, right?
Number 3, you have to solve for the function, yes. Same with 4 and 5. So 3, 4, and 5 are really the only long ones here. The rest of them should be somewhat quick. This one's yes. And I do this.
Oh, okay.
You can still work together. I mean, like, I wasn't trying to make you like silent. I'm just trying to make sure that you're doing work. You listen to music, yes. So you see how when I do this, it crosses twice? That means no. And then like here, it doesn't. It only crosses one time. So yes. Yep.
Is it up?
Good.
Sorry.
So it's originally dividing by 2, right? It's really 1/2. How do I get rid of the
Why are
2?
you laughing?
I'm off.
Sorry.
So you can put like it just right out in front. You can. You definitely can. Yes. So I wanted to just kind of make sure that you're understanding the homework part.
Wait, so number,
Really
what's
good.
your number 6?
Mhm.
Would that technically cost me twice or once? Number 6. Because it's like riding on the line.
I totally get that. It's only gonna cross one time. Yeah, it's very close to see that. I can understand why.
Okay.
Just gonna kind of.
Wait, so number 8 would be new, right? Because it doesn't even cost.
Let me see. And you can work together. You can listen to music. Homework. Day 1. Yeah, I don't know how people do that. It's insane.
You would.
Listen to music that loud. My ears would. Like, that bothers me when that goes off. That's how bad my ears are.
Why?
It actually can cause a lot of damage to your eardrums. Yeah. Yep. And that's why you can't hear when you're older.
Wait, so
I see ya. Hold on. Where the heck? Do I have the key? I don't, but I can maybe help you. Good. Now, how do I? So yeah, I understand why. I probably should have wrote it a different way, but technically the y is being divided by 2. Because when you multiply straight across, isn't it y divided by 2? Because really this means like 1/2 times y, right?
Yeah.
So like when you multiply that, because remember how like the y would technically, I know it's hard to see that. Wouldn't it be y over 2? So then what would you do? Or,
Plus 1/2
so,
y plus 6.
so it's called what multiply by the reciprocal. What's the reciprocal of 1 over 2?
Hey,
Two
give
over
it back.
one.
So you see how you're multiplying by 2 instead of
Oh.
dividing? Because when you divide by, you can put it that way, but that's really improper math in my opinion.
Okay.
Yeah. So you're like
But
whenever
is it
you,
right though?
it's right. Just put 2 times that.
So you put it 2 in front of it?
Yeah, because dividing by 1/2 really means multiplying by 2.
Okay, alright.
Remember even like last time when we did the keep change flip,
Yeah.
dividing by 1/2.
No, I need those.
Dividing by 1/2 really means that you're keep, change, and
Multiplying by
flip.
two.
Yep, means you're multiplying.
So put the 2 in
Yep,
front of
very
it.
good. Yeah, that's a very weird worded question.
And
Yes.
then put the 2, what would I put in front of it?
A -5 instead.
Oh, so whatever on the bottom.
Yeah, it becomes the
Okay,
top.
alright.
Yep, good question.
And my earpods case.
Come on up. Yeah, let's not talk about that, please. That'd be great.
You took my gum and my headphones case. Yes.
You can come up.
It's in this-
Come up.
it's in this-
I know how to do 3, 4,
So
5.
I drew on them.
this is supposed to say 1/2, right?
Like all of this. Like I started,
You got it.
but I don't know what to do now.
I'm going to do 3 with you really quick. So it looks like this. A lot of you are getting confused because of this 1/2. Remember what we learned last chapter? Keep, change, flip. When you're multiplying a fraction by, or you're dividing by a fraction, you change the sign and you flip the fraction. Okay, because really what this means is x over 2. Okay, 1/2 times x really means x divided by 2. Okay, if you want to write that way, you can. Otherwise, when you solve, I have my x over here and my 1/2 y plus 6. I'm going to walk you through this one. And we're running, well, we have 7 minutes. So I would subtract the 6. You're right. Is this the same problem? Because I feel like mine did not convert correctly. It did. I would subtract the 6, and I get x minus 6 equals 1/2 y. Now let's talk about this. A lot of people are doing this, and I understand why. A lot of you are going divide by 1/2. Fine. Remember what we learned last chapter, though. Keep, change, flip. Dividing by 1/2 really means multiplying by 2, right? Because when I multiply by 2, look what happens. They cancel, and that's the goal. So really, your final answer is 2 times x minus 6. Oop, there goes the pen. If you want to be math superstars and distribute, and you can, otherwise you can leave it. It's fine. All right, so dividing by a fraction really means multiplying by the denominator.
Also, you just
So it just flips, yeah. So in order to get rid of it, you have to multiply. And that's going to apply to the following one, okay? So your final answer,
yeah, number 5 is the same.
yeah, so now you can apply that to 5. Is that.